Okay, great. Good evening, boss. We can hear you.
You can hear me now.
Yes.
I'm on my episode. Hey. Oh. Will this episode be work now? What about now?
Yes, it's fine. You can just let me start the
You
introduction
can
while
hear me
you.
now.
Yes, I can. I can hear you, boss.
Yeah, please just reply this person asking if he's still holding or not.
Okay.
Let's just start and see what we can do.
Okay. So we can get started. You want to share your screen?
I believe you can see my screen already.
Yes, I can.
Yeah, are you
I
not
can.
doing
The
this thing? What's it called? That
the streaming.
yes.
Yes, I need to pause. Okay. Okay. I'm going live now.
All right.
Hi. Good evening, everybody. We apologize for starting this a bit late. We had a couple of technical issues. We have finally been able to resolve that. So this evening we are continuing with our section on the Linux Weekly Study Series, and we have with us also our fantastic speaker that has been sharing with us his knowledge for the past few weeks, Mr. Latif Taiwo, and is guaranteed to be another knowledge section. And I'm sure that we all have our pen and pads and our computers with us and ready to follow up as he teaches us this evening. So without much further ado, I would like to open up the floor for Mr. Latif Taiwo so that we can get started immediately. Thank you.
All right. Thank you, Mr. Olumide Pakorile. Good evening, my audience. Good afternoon, good morning, wherever you are joining us from. Today we'll continue with our Linux weekly study series, and the topic for today is monitoring and performance optimization on Linux systems. Uh, Prior to that, I want our audience to boot into their Linux system, or if you want to use a virtual machine from Azure, you can quickly launch that. And I was actually trying to launch that, but prior to uh, fully launching that, I will be using my primary operating system, which is a Debian-based operating system called Linux, and I believe we can follow along with it. Now, uh, before talking about monitoring and performance optimization, there's something we ought to talk about. which is, I believe you can all see my screen. Manage the startup of processes and services. Olumide, can you kindly confirm that if you can see? Okay, it means that I'm not sharing this. Is it now showing or it is still the poster that is showing? Moderator. All right, if you cannot see that, we'll use this my, yeah, I believe we can all see this. Olumide, please kindly confirm to me that you can see the topic that I'm sharing. Sorry, I'm trying to move this. I'm sharing my entire screen and you should be able to see monitoring and performance optimization in Linux. Olumide, you can speak up, please. Now, before talking about monitoring and performance optimization, I want to quickly talk about how to start, stop, restart, enable, or disable processes in Linux. So to check the status of a process on your Linux system, all you have to do is sudo systemctl status ssh, and I'll put in my password. You can see that the SSH service is actually loaded when it is disabled and it is not active. That means it is not running. Olumide, can you now see my screen? Or my slide, which I'm actually sharing on another browser window. Now, while we are trying to fix the okay, let me just keep explaining. So to check the status of a service, you use the systemctl command, but you have to run that with sudo because it needs super user privilege. So you use sudo systemctl status, then the name of the service. SSH is the name of the service I'm trying to check the status of. To start that service, for example, like my service that I checked, the SSH service that I checked, to start it, you use sudo systemctl status ssh. To restart that service, sudo systemctl restart SSH. If you want to stop the service, you put the stop command. Like you replace restart with stop, sudo systemctl stop SSH. If you want to enable the service so that the service will always start whenever the system boots or whenever you restart or reboot the system, you use sudo systemctl enable SSH. If you want to disable the service so that it will not auto start whenever the system is rebooted or whenever the system is booted, you use sudo systemctl disable SSH. Now, another command to use, which is actually an old command, is the service command, service SSH status. This simply checks the status of the SSH service. This should be check status using the SSH and using the service command. Now, in the same vein, we can actually check for, we can actually restart or stop the SSH service using sudo service SSH start or sudo service SSH stop. So that is a brief overview. Can we now see my screen? Olumide, you did not, I believe you did not enable live, is it live streaming or there's something? The audience are supposed to see my screen, and if they cannot see my screen, it's a problem, and I'm sharing my screen. I'm sharing my screen, so I don't know what we are doing wrong. Let me share again, and we share only this browser in particular. I've shared my screen now, and I'm sharing the entire screen. Let me stop sharing and reshare entirely.
So your screen is visible now, Mr. Latif. Yeah.
I believe you can hear me, right?
Yes, I can.
All
Please
right.
go ahead.
So, to my audience, like I was saying, before we dive into monitoring and performance optimization in Linux systems, I quickly want to brush up through how to check the status of services, or how to start, restart, and stop the status of services. So, for example, if we want to check the status of the SSH service, we use the command sudo systemctl status SSH, which I used here. Let me quickly board this. I believe my terminal is not big enough. So if I want to restart the service, the SSH service, mind if you restart the SSH service and there are people connected to your server via SSH, they will be disconnected. So that has been restarted. I can check the status again. You can see it's now running because I did a restart. I can actually stop it using sudo systemctl stop SSH, and it will be stopped. And if I check the status, you can see that it is inactive, it is dead. We can enable it to always start whenever we reboot the system, or whenever we boot the system. This will change to enabled. You can do sudo systemctl enable SSH. This means that my SSH service will always start whenever the system boots up or whenever they restart the system. So, and we can see something that is create symlink from this directory to this. We'll talk about Symlink towards the end of today's class. So I want to quickly check the status once again. We can see that it's enabled. So if I restart this now, and whenever I restart my system, the service will always be running. But this my system is not a server, so at the end of this session, at the end of this, when I end this slide, I will just stop the service and I will make sure it's disabled. So a shorter way to quickly check if services are running or they are stopped or they are enabled is using the service command, and it's actually a deprecated command, but it is still very, very useful. Sudo, it's not only we may have our server running a lot of services. It may be running the Jenkins service, it may be running the MySQL service, probably it's a database server also. So it depends. So this SSH is just an example. So it depends on whatever service you are running on your Linux server. So I want to quickly use the service command to check the status of my SSH service. I use sudo service SSH status. You can see this brings the same output. So in the same vein, I can actually do restart. So the only difference is that for the systemctl command, the service name comes last, but for the service command, it is the service name does not come last. It is what the action you want to check for, be it status, start or restart, that will come last. So that is it. So a quick one, let me quickly stop my SSH service. This is not a server, this is my primary operating system. I'll disable it and I will stop it. Disable. You can see here it's enabled. So when I disable now, this will turn to disable. Disable SSH. So if I run service status command again or systemctl, you can see this is disabled, but it is running. So I'll quickly stop it. Sudo systemctl. I love to use the systemctl command because it is the newer command. SSH. So the systemctl SSH. Sorry. Disable SSH. So we can check the status again. You can see it is disabled. Okay, I want to quickly stop it. Sudo systemctl stop SSH. So, and since it's disabled, whenever the system is rebooted, it will not automatically start. So next we have monitoring and performance optimization. For some reasons, let me quickly use this. So you have to monitor and ensure optimization of your Linux server, including the services running on it. So for resource monitoring, we have CPU usage, memory usage, disk usage, and network usage. Now for CPU usage, we can use several commands such as the top command or the htop command to check for CPU usage. And another similar command is the ps command. So high CPU utilization could indicate a process that is consuming too much processing power. Yes. So I will quickly draw ps aux. We will see several commands and other services that are running, but a quick one, I will do the top command. You can see that the top command gives us several information: the user, the process, the nice value, and some other things. We have the CPU usage. This is what we are concerned about. We can see that the process command gives us the top command. It shows us the process or the services that are consuming a lot of memory and a lot of CPU at the top of the output. We can see that this web content is consuming a lot of memory. Firefox also is consuming a lot of memory and CPU. So we can actually use the downward navigation key to navigate down. I can use Ctrl C to exit out of this. I can pipe this to my grep command and do Firefox. Let's see. We can see. So this is for CPU and this is for memory. So that is what the top command does for us. You can also use the htop command, but I don't think the htop command is installed by default here. The htop command is not installed on my system by default. So with this, I'll quickly use the tmux command. Tmux allows me to manage to work on several shell sessions on the same terminal window. So when I type tmux, I'll press Ctrl B and I'll try to split my terminal into two. So on one part of my terminal, I'll quickly try to install the htop command, the htop utility, sudo apt install htop. So while this is running, okay, htop is not being installed for some reasons, and I will not want us to waste a lot of time there. So quickly we'll move on. Let's try to explore the np start command. Man np start. Okay, it reports processors related statistics. So I'll do np start. So this tells me, it gives me information related to my processor. We can say this is my Linux version and I have four CPUs running. This is the, what's it called? The my processor type, the bit, 64-bit processor. So I have some other information here which may be obscure to kind of explain, but I quickly open a new tmux shell. So I'm still in a single terminal and I have another shell here, and I want the np start command again so that I can view this clearly. This gives me a better view, and I have that all CPUs are listed here, GUSR, the NICE, CIS, and what have you. We have them relating to, and several information relating to how much of the CPU these processes are consuming. So moving on, for memory usage, keep an eye on memory usage with free top or htop command. So if, for example, you want to check your memory usage, you use the free command. If you pass the -h argument to your free command, it will display the free memory you have for you in a human readable format. So on my system, my total memory, which is my random access memory, is 8 gig, and this is displayed in gigabits in 7.7, and I've used 2.6 gig. We have this free. This is shared, and the available memory I have is this. And I have a swap memory, which I've explained in one of our previous sessions. Now, moving on. If you want to check disk usage, if you want to check the free disk you have, you do this df dash, you pass the -h flag to see it in a human readable format. So, and this will list for you this free disk that you have. So the column under available tells us the size, the free disk size that we have, and we also have the points on which they are mounted under this mounted column. So moving on, if you want to check network usage, you can use the if command or the ip command, and all of this, I've explained all of this in our previous sessions. Now, like I mentioned before, the top command will show the most CPU intensive command at the top of the list. It shows more processes than the PS command. So this is what they are saying there. This is what we have there. My system is currently low and I may have to quickly. So if I do PS1, this tells me the process ID. This gives me information regarding the process ID 1. If I do, if I want to see this output in a user-friendly format, I'll do PSU-1, PSU1. So this gives me this information in a more user-friendly format. So if I want to see information regarding the current user logged into this system is Savitech, we can see that using this command, if I want to go up because I have TMOX session up, I'll press Ctrl B and I'll use the page down command or the arrow keys to check for these things. So we have a lot of things here, which time will not permit us to quickly go through them, but these are things that allow you to monitor your system so that you know the processes that are consuming too much CPU or too much RAM. So we have a lot of information here. And my default shell is Z shell, ZSH. So moving on, process monitoring. Under process monitoring, we talked about process monitoring. I talked about the top command. So we can check for logs under the using syslog, or we can actually check for logs in the var/log directory. So I'll cd into cd/var/log. I can list the directories here. We can see several logs. I want to quickly analyze this my boot log and I will cut it. You can see information about, okay, I cannot just cut into that because it requires sudo privileges. So we can view several information here. We can see this information. We can see a failed we can see that a particular process or service failed to start, and it requires us to enable support for additional executable binary formats. So you can check many of those things here. We can see another failed command. I will quickly use PageUp to view this. You can see that when you started this, we can see a lot of information in our boot log. Mr. Olumide, if we have any question from the audience, let's quickly ask. I want to quickly put on my generator because power has been interrupted here. So I'll be back in a jiffy. You can quickly ask the audience to send in their question while I put on my generator.
Okay. Um, just reaching out to our audience. Apologize. This is Nigeria. We still have a lot of issues to battle with. So in case you have questions, please send in your questions in the chat. Please send in your questions. Our speaker will be more than happy to take them.
So let's quickly move on. Time is not by our side, but we'll see how much we can cover. We'll try to cover what we have for today. So that is the boot log for you. You can check more things. If, for example, come in, let me do an ls and try to go up and see. You can check these messages. I've seen something on messages, and we'll still check through our syslog to check some things. Syslog 1, I have messages .1. You can check messages. So let me cut messages. You will get a lot of information. You'll get a lot of information regarding let me quickly go up. But there are lots of information here. So about certain kernel processes, and this information will guide you through how you troubleshoot problems with your Linux system. If, for example, you can check syslog, we can actually check syslog by cutting this syslog file. So if, for example, I want to check for lines, let's say I'm trying to check for things related to, let's say, let me say, for example, I want to check for this free desktop. I want to check for errors or messages regarding this free desktop. I will just create for lines having free desktop here. And we can see that on the 1st of August, at this time, activation via systemd failed for dbus for this free desktop due to some reasons, because the unit dbus org.freedesktop.resolve1.service was not found. So these informations allow you to better troubleshoot your system. If, for example, there's an application you are trying to look into, you're trying to get better information as to why it's not coming up, or as to why probably the service is not running, you can check the /var/log directory for logs, and we can see that we have a lot of logs here. I even have logs regarding Nginx, I have logs regarding MySQL, I have logs regarding the boot processes and all of that. But time will not permit us to go through all this. Audience, you can actually skim through several of these logs and read through them to check for several informations. So I'll move on. So if, for example, I want to use the syslog, I want to check for processes that contain specific names. For example, syslog, I'll use pgrep-a syslog, pgrep-a syslog. So this is a process that contains the name syslog. Moving on, we can use the journalctl command. Is a very, very useful command for troubleshooting. To start with, I can check the full path to the sudo command using the which command. I can do which sudo. You can see that this is the full path to it, usr/bin/sudo. I can do journalctl /usr/bin/sudo. if I go to the right, I will see information regarding this. This allows me for troubleshooting. This allows me to troubleshoot problems with the sudo command. If, for example, there's a problem with, let's say, SSH, or let's say the MySQL service, you can actually do a lot of troubleshooting using this journalctl command. If, or for example, you are having a problem with Docker, maybe Docker is not running for some reasons, or it is running, you're not able to do some things, you can actually use journalctl to do some troubleshooting. You pass the -u flag and you type the name of the service, for example, SSH. So because that service is not running, that is why this is not coming up. So which service can I use to quickly check for this? I can actually use, okay, let me do the same thing with sudo, but it's not a service running. Let me quickly go to my slide. So to view logs generated by, you can see, so you can either use SSH or use sshg.service. So if I want to check for logs after 2 a.m., I can do journalctl-s capital S 0200. This will show me logs after 2 a.m. and we can see several information regarding this. My user, you don't have to find this boring. As a Linux system administrator, you need to know how to check for these logs, and it will help you for troubleshooting and also for system maintenance and all of that. So I'll quickly move on. If, for example, I want to check for logs between 1 a.m. and 2 a.m., I'll do, let's say, between 2 a.m. and 3 a.m., I'll do journalctl-s 200-u 03:00. Okay, there were no entries at that time. All right, no entries. We'll move on. Now, we can do process priority and affinity. There's something called nice and renice. So the niceness value can be between can be a number between +20 and +19. Sorry, -20 and +19. The lower the number, that's the lower the niceness value, the less nice that process is, and a lower number means that it means a higher priority for that process. So a lower number means a higher priority for that process. For example, okay, so since this is the syntax, the process nices syntax, the nice command -n, the value 11, then the process name bash. So I can do nice -n 11 bash to give a niceness value of 11 to the bash process. So we can actually check for process list of all processes and their nice value, ps lax. Let me pass the bash command to this. Let's see what will come up. Okay, I have to grep for the value. ps lax would list processes including their niceness value, and we will see that under the nice column, you can see it here, ni. So you see that value there. So this is -20. This is niceness value of this command, and we have other niceness values. We can see the one, this 19, and we have many other informations here. So let's quickly move on. To display further processes, that's parent processes of other processes, we use ps fax. You will see the parent process of tmux, which I'm currently running now, is the Z shell. You can see it. It displays it and actually points to the parent process. So we have several other processes. For example, the usr/bin/z shell. We will see the parent process here. So the bash process, you see the parent process here. So these are all other informations that we can see. And we can actually use FAUX, PS, FAUX to see the CPU usage in addition to the parent processes of other processes. So if I'm to scroll up, I will see CPU usage. You can see the column for CPU usage here. And we can actually scroll down to see more other informations. So a quick one, we'll move on. Time is really not on our side. So file system optimization, you choose appropriate file system. There are several file systems for Linux system. On Linux system, we have ext4, we have XFX and all of that. But on Windows system, it is NTFS file system that is peculiar to Windows system. But on Linux system, we have ext4 and also have XFS. Those are the ones I can quickly remember now, but I believe there are a lot of other ones. You consider using solid state drives, SSD, for better performance. Yes, we all know that SSDs have better performance or provide better performance compared to HDDs. Use efficient web servers and database servers. One of the best web servers you can use, or one of the most efficient web servers you can use, is either Nginx or Apache. And I think I actually have, let me quickly check. I think I actually have Nginx installed here, but it's not running as a web server. Sudo systemctl status Nginx. I'm not too sure. Yes, I have it here, but it's not running as a web server. So it's a high performance web server and a reverse proxy server. So, and also use databases like MySQL or PostgreSQL for better performance and resource utilization. So I want to quickly talk about symbolic link and hard link. So a symbolic link, which is sometimes called soft link, but it is actually wrong to call it soft link. The correct thing is symbolic link. You hear some authors say soft link, but based on my research and based on my knowledge, it is best to call it symbolic link. So how we call symbolic link and hard link? Symbolic link, also known as symlinks and hard links, are two types of links used in Unix-like operating systems like Linux. Both types of links allow you to create references to files or directories, but they have some differences in how they work and what they point to. I believe we can all see my screen, so I really feel I don't need to go too far. So a symbolic link is a file that acts as a pointer to another file or directory in a file system. Take for example, Windows user, if you install a new application, you will discover that at the end of that installation, the application may tell you to create a shortcut to that application on the desktop. Yes, so that shortcut created on the desktop is a symbolic link or a symlink to the actual file part of that application, to the actual, it is a symlink to the file part. It's a symlink to the part. How will I say it now? Yes, it is a symlink pointing to the file part necessary for the applications to work. I believe we understand me. So that is what symbolic link is. It is it's a link. It's a file that acts as a pointer to another file or directory in the file system. It contains the part of the target file or the directory to which it points. Symlinks can cross file system boundaries. Yes, you can use symlink across several file systems, be it ext4, be it XFS. If the original file or directory is moved or renamed, the symbolic link will become broken or dangling, meaning it's pointing to a non-existing location. So that is one issue with symbolic link. So you don't have to move or rename the original file or directory. Now, to create a symbolic link, you use the ln-s command. So a quick one, I will go to, let me quickly see the things I can quickly create symbolic links for here. So we can see I have several PNG files. So I can decide to create a symbolic link to this error.png file. This is a picture I have on my system here. Now to create a symbolic link to that file, I'll use ln-s path to target, then path to symlink. Path to target means that the path to the file I want to create a symbolic link for. Then path to symlink. Now I'll do ln-s. What is the path to the target file? I'll do, this is my desktop folder, error.png. I want to create a symbolic link for it to, let's say, my documents folder. I'll do this slash, let's say, I'll just put picture.png. This will create a symbolic link to it. This means that picture.png will be a symbolic link pointing to error.png. And whenever I come here, I can decide to come to my documents folder here, and I'll pipe and grep for my picture. Sorry, I'm not in my documents folder yet. So picture.png. If I do ls-l for my picture.png, I should be able to see that it is a symbolic link pointing to, yes, I will see that it is a symbolic link pointing to my error.png file located in my /home/savitech/desktop directory. Note that here I did not have to type my directory in full. Why? Because I've always told us that the tilde sign means the home directory of the currently logged in user. So this tilde sign stands for /home/savitech. So I did not type it fully here. So this L here, starting this command, tells you that this picture.png is a symbolic link. And you can see fully that it points to the target file. It points to the original file. So that is symbolic links for you. To know more about symbolic links, you can actually use the read link command. Read link picture.png. It will definitely tell you, it will just tell you the symlink to that command, to tell you the symbolic link to that file rather. So that is a quick what's it called? That's a quick brief of, or a quick note on symbolic link, and it is very, very important in Linux or anything or any technology related to Linux. Whenever you do some file installation, you see that symbolic links are created. Yes, it's similar to what I explained when I first start explaining this symbolic link, like that it is similar to installing an application on Windows, such that a shortcut gets automatically created on the desktop. That shortcut is actually pointing to the actual file or the actual files necessary for the applications to work. So with that, I move to, so this is what I've just explained, that this L here tells you that this is a symbolic link. So whenever you do ls, if you see an LL, if you see an L at the beginning of the command, you should know that that is a symbolic link. So this L here tells me that picture.png is a symbolic link pointing to error.png located in the desktop directory of our currently logged in user. So moving on, I will talk about hard links. A hard link is an additional reference to an existing file or directory. All hard links to the same file share the same inode. Inode means file metadata, and they essentially point to the same data blocks on the disk. Hard links cannot cross file system boundaries. So if you ask that what is the difference between a symbolic link and a hard link, a symbolic link can cross through file system boundaries. That is, they can cross two different file systems, but hard links cannot cross through file system boundaries. Although there's an exception for hard links, the ext2fsd file system in Linux is the only exception to this cross boundaries for hard links. If the original file is deleted, the hard link will still retain the file data until all hard links are removed. Creating a hard link does not increase the disk space usage, since it refers to the same data block as the original file. So to create an hard link, use the ln command without the -s option. So for example, I can decide to create an hard link for this same file. I'll do ln desktop /error.png, and I'll create a hard link. Let me just use another file, scpix.png. So this is a hard link now. I'll come here and we can actually check that hard link. I can check, so to check hard link, I think briefly, if you want to check hard link, we can use the start command. Start error.png. So we can see the inode. This is the inode. And we can see that the link has increased to 2. That tells you that there's a hard link pointing to, there's a hard link for this file. So with this, we come to the end of today's session. So now let me quickly talk about the limitations and considerations for symbolic link and hard links. So in summary, symbolic links are references to file paths, while hard links are additional directory entries pointing to the same inode and data blocks. Symbolic links are more flexible since they can span different file systems and can link to directories, but they may become broken if the target is moved or removed, like I mentioned initially. So on the other hand, hard links are limited to the same file system and cannot link to directories, but they provide more robustness as they continue to point to valid data even if the original data is deleted. So with this, I come to the end of today's session. If you have any question, you can quickly ask. Olumide, if there's any question, please. The audience can ask their question.
Okay, can you hear me?
Yes, I can hear you. Let them
Okay.
send in their question.
Yes, it's been another fantastic section. Please let's send in our questions. Currently, we don't have any questions in our chat. So if you do have questions, feel free to share them. I'm sure that we've learned a lot. I personally have learned a lot while this was going on. Please let's share our questions. So, Mr. Latif, I wanted to ask if if it's going to be possible to get this the slide. I'm sure that we've all learned a lot while the section was going on. Really want to appreciate all that joined. I also apologize for the network issues that we had initially that didn't allow us to start in time. But that has been resolved now, and so in the absence of any question, I take it that the section today was understood by every one of us that's on the call. I also wanted to ask Mr. Latif if it was possible for us to get these slides. Okay. Okay, so I think we can take that as there's no questions for this week. Mr. Latif, I don't know if you'd like to share any final information with us before we end this call for today. Mr. Latif, can you hear me? Okay. Okay. So thank you everyone that joined us today. It was a very interesting section. Though we started late due to some unforeseen circumstances, but at the end of it all, we were able to have a fantastic session. Today's session was on monitoring and performance optimization, and we had with us also Mr. Latif Taiwo, uh, fantastic speaker who has been taking us through this journey all along. And I'm sure that we all learned a lot. And if you do have questions, you're always free to comment in the chat or reach out in the WhatsApp groups. I believe that at the end of this section, we would have all learned a lot and be able to properly administer Linux systems. Thank you very much, everyone. Look forward to seeing you again next weekend. Enjoy the rest of your evening and do have a great week ahead. Thank you.